Good day. Today let's see what a binary tree is. Before going to a binary tree, let's see what a tree is. A tree is a collection of nodes connected by directed or undirected edges. It is an extension of linked data structures such as linked lists to a structure that may have multiple relations among the nodes. The advantage of a tree over linear data structures such as linked lists and arrays is the time complexity of searching an element, which is less than a linear time. A linear time implies O of n. Here in the case of tree, it is O of log n. So now we know about the tree. Let's see what a binary tree is. It's a kind of a tree where each node can have no more than two children. Let's see what it is. So if we consider one as a data here, the one is placed inside a node, which this node can have at most two children, which are also nodes and which do contain data in them. So these two are called nodes, and these nodes are connected with the help of edges. As we know, the edges can be directional or unidirectional. As we can see, each and every node has at most two children. That means each and every node can have 0, 1, or 2 children. So if we see a binary tree or any tree, the node which is the topmost, which is at the top of the tree, is called the root node, and the nodes which do not have any children are called the leaf nodes. Binary tree is the idea behind the data structures such as BS trees and red-black trees, for which the search time complexity is O of log n. But the binary tree which does not follow any logic while inserting the nodes cannot achieve this. Now that we know what a binary tree is, let's go ahead and create it. So as there is no particular logic while inserting into a binary tree, we will insert in a level order, meaning we select the node which does not have the left or right child, level by level from left to right, and insert the node into the first node of that kind. Let's see how. Let's consider the following input: 1, 2, 3, 4, 5, and let's try to insert one by one into the tree. So while inserting each input, we need to follow the following procedure. Okay, let's see how to insert one into the binary tree. So first, when the one is inserted, we need to first check, is the root node already created or not. If it is not so, we need to create a node and keep the root pointer pointing to that. So now let's try and insert the next input, that is 2. While inserting 2, we need to check whether the root node is already present or not. And yes, it is present. So we need to find a node from left to right, top to bottom, which occurs first, which does not have left or right child. So we need to follow the following procedure. So what we do is we consider a queue data structure. A queue is something which follows first in first out order of inserting elements. That means the element which is inserted into the queue first is given higher priority while extracting it or popping it out. So let's consider a queue data structure. So we need to insert the first element into the queue, that is 1. So in order to continue the loop, the node which is at the front of the queue should contain both the left and right child. If it does not contain, we will simply mark that as current node and then pop it out. So as we can see, the current node does not have left child. We will insert the new node to the left of the current node. So let's try and insert the next node, that is 3. Similarly, we check whether the root is present or not. Yes, the root is present. And then We check whether the frontmost element of the queue contains left and right child. No, the right child is not present. So go ahead and pop it out. And then, as the current node does not have right child, we need to insert the new node at the right position of the current node. Similarly, let's insert 4. Yeah, while inserting 4, we need to consider the root node, if it is present or not. Yes, it is present and it is not null. So we need to insert that into the queue. And we need to check whether the frontmost element in the queue has both left and right child or not. Yes, both are present. So go ahead and insert both of them into the queue. After inserting all the children of the current node into the queue, we need to pop it out. So now the current node becomes the frontmost element of the queue. That is 2. We need to check whether the frontmost element of the queue contains both left and right child or not. No, it does not contain left child itself. So we need to pop it out. And then, as the current node does not contain left child, the new node is placed at the left position of the current node. Let's see how to insert 5. Yes, we need to check the root node. Yes, it is present, it is not null, so we need to insert that into the queue. Then insert all of its children into the queue. Yes, all the children are inserted, we can pop it out. Then consider the frontmost element in the queue. If it contains both the children, then we need to insert them into the queue and pop it out. And if it is not so, we need to insert the new node into the current node, which is the frontmost element of the queue. If the left is not present, then to the left, else to the right. That means priority is given to the left node. But in this case, left is already present, so we need to insert the new node at the right position of the current node. So this is how we insert elements into the queue in the level order from left to right, level by level. So let's try and program it.